Welcome back. This lesson is the final lesson in the hardware unit, and we're going to be focusing on the network side of things. By the end of this lesson, you should be able to understand that a computer needs a network interface card to access the network. You should also be able to understand what is meant by and the purpose of a media access control address or a MAC address, and you should also be able to understand the purpose of an IP address. We're going to cover the different types of IP addresses, IPv4 and IPv6, and finally, we're going to be discussing the role of a router in a network. So let's start by defining what a network is. A network is a group of computers or devices which are connected together using cables or some sort of wireless technology. To access the internet or perhaps to join your school network or any type of network, special hardware is required, such as the network interface card. The purpose of the network interface card or NIC is to connect devices to a network. And in addition to that, you need some sort of transmission media like a cable or perhaps some kind of wireless medium like Bluetooth or Wi-Fi. If a wireless network connection is required, then a wireless network interface card, a WNIC, and a router or a wireless access point is needed as well. Now on screen you can see examples of all three of those. Most network interface cards nowadays are WNICs because they allow both physical and wireless connections. And of course, you should be familiar with the router. Perhaps you have one in your home, and the Ethernet cable that allows you to connect using a wire. Now, in order for devices to connect to a network, they need a MAC address. Every NIC or WNIC contains the media access control address, which is given at the point of manufacture, which uniquely identifies the device on a network. This address is rarely changed after it's decided at that stage. This MAC address is used to send or receive data to the device over a network. And MAC addresses are usually written as hexadecimal and are made up of two parts of 6 digits each. Each pair of digits is separated by a colon or a dash. The first part is the manufacturer code. So the first set of 6 digits is the manufacturer code, and the second set of 6 digits is the serial number of the device. And it looks like the address on screen, 4A:33:22 and so on. When data is sent over a network, the MAC address is inspected to ensure that data reaches the correct destination. Every data packet will have a sender's MAC address and a destination MAC address. Now, sometimes we want to send data across the internet, and for that, you need an Internet Protocol address, which is called an IP address. This IP address is allocated by the network, normally a router, or an internet service provider, and can be either static, which is fixed, or dynamic, which means it changes. This IP address is used to uniquely identify your current location on the internet. Now, MAC addresses are used within a network, and IP addresses generally are used over the internet, so they provide the same function. They uniquely identify a device. Why do we need both? Well, IP addresses generally identify your location on the internet, and the MAC address identifies your device at the location, because at your location, for example, your home, you might have a number of different devices, which might be your smart TV, your laptop, your mobile phone, and so on. So data packets need to know where to go once they enter your network. Using both allows us flexibility to deal with various types of network setups. A typical IP address is defined by a set of 4 binary digits separated by a full stop. Each set is equivalent to 8-bit binary, so a typical IPv4 address takes 32 bits, and it looks like what you see on screen, 10.121.55.221. Now, IP addresses can have different structures, namely IPv4 and IPv6, and you need to know about both of them. IPv6 builds on IPv4 and uses 128 bits. 32 bits has an address limit because 2 to the power of 32 means that there are over 4 billion addresses. But since the number of devices that need to connect to the internet is much more than that, we needed a new structure. Now, the address that you see on screen is an IPv6 address, and its structure uses 8 sets of 4 hexadecimal digits separated by a colon, whereas IPv4 uses 4 sets of denary digits separated by a full stop. Now, you need to make sure you remember this because this is a typical exam question. IP addresses can also be static or dynamic. Now, dynamic IP addresses change every time a device connects to the internet, whereas a static IP address remains the same every time a device connects to the network. Dynamic IP addresses allow recycling of limited IP addresses, so if your device is not in use, your IP address is given to another device. A static IP address means that IP address is assigned to you and it's normally given to you by your ISP. Now, both MAC addresses and IP addresses are useful when we want to send data across a network. The device that makes that happen is a router. A router is a hardware device that inspects data packets which are sent over a network and routes them towards their specific destination on a network. And that destination could be within a network or on the internet. When a data packet arrives at a router, its destination and sender IP addresses are inspected. If the current router is not the destination, a routing table is used to identify the quickest route to its destination. The packet is then forwarded to the next router to help it reach the destination. So make sure you are aware of how a router works. It inspects data packets, it reads their IP addresses, both senders and receivers, and it then routes them by forwarding them to the correct destination. Okay, that's all there is to network hardware. Hopefully you can answer the following questions. You should be able to state the purpose of a NIC, a WNIC, and a router. You should be able to describe the differences between IPv4 and IPv6. You should be able to define MAC addresses and explain their use in networking. You should be able to explain the role of a router in transmitting data packets, and you should be able to explain the difference between static and dynamic IP addresses. That's all for this particular lesson. If you do have any questions, please get back to me. Otherwise, I'll see you in the next one.